Flappy Bird is the perfect first game in Unity. One input. One mechanic. And it is the smartest way to learn Unity from absolute zero. In the next 15 minutes we build the whole thing together, no experience needed. Quick, honest heads up before we open the editor. If this is your very first game, the thing you will want next is a plan. So I made a game dev starter kit, $19, with a 30-day roadmap for exactly what to build after Flappy Bird. It is completely optional. The link is below. Now, let's build. Here is exactly what we are building. A bird that falls under gravity. A tap of the space bar that makes it flap upward. Pipes that scroll in from the right with a gap to fly through. A score that ticks up, and a game over screen that restarts on the next tap. That is the entire game. Unity is a free, professional engine, and the code is C#. One quick note before we start. Unity's editor is a hands-on desktop app, so instead of tiny screen recordings, I am going to show you clean component diagrams and real, correct C# code. Every editor click is in the written guide on screen, follow along there for the exact screenshots. Let's set up the project. Create a new 2D project in Unity Hub, and you land in an empty scene. A scene is just your level, the container that holds everything on screen right now. 3 words you will hear constantly. GameObject, Component, and Prefab. A GameObject is any object in your scene, the bird, a pipe, the camera. A component is a behavior you bolt onto a GameObject, like a rigid body for physics or a script you wrote. And a prefab is a GameObject saved as a reusable template, so you can spawn 100 copies from one blueprint. Hold on to those 3 ideas. GameObjects made of components, and prefabs you stamp out copies of. Almost everything in Unity is one of those 3, and the whole game clicks together once they do. Let's make the bird. In the editor you create an empty GameObject, name it bird, and drop your bird sprite onto it with a sprite renderer. That is the picture. Now we make it fall. Add a rigid body 2D component. That is the single line that hands the bird over to Unity's physics, gravity now pulls it down automatically. In the inspector, set gravity scale to about 3, so it falls with a nice weight. Then add a collider 2D, so the bird can actually hit the pipes later. Now the fun part, the code. Create a new C# script called bird, attach it to the GameObject, and open it. Here it is, and it is genuinely this short. At the top, the class extends monobehavior, that is what makes it a Unity script you can attach. We grab a reference to the rigid body in start, using getComponent. Cache it once, use it forever, that is the pattern. The flap lives in update, which Unity runs once every rendered frame. If input.getKeyDown, keycode.space, we set the rigid body's velocity straight up. GetKeyDown fires once per press, not while the key is held, that is exactly the Flappy Bird feel. One tap, one flap. Look closely at that one line. We set rb.linearVelocity to a brand new vector 2, 0 across, flap force up. We do not add to the velocity, we replace it. That instant reset is why the flap feels so snappy every single time. One important note on that property name. In Unity 6, the rigid body's velocity is called linear velocity. In Unity 2022 and older, it was just velocity. If you are on an older version and the code will not compile, that rename is why, everything else is identical. Gravity comes from the rigid body. The flap comes from one line of C#. Press play, and your bird falls, and taps to rise. You already have the beating heart of the game. Now the obstacles, the pipes. A pipe is going to be a prefab, so we can spawn as many copies as we want. This is the single most important idea in Unity. Build a thing once, save it as a prefab, then instantiate it over and over. In the editor, make a GameObject called pipe. Give it a top pipe sprite and a bottom pipe sprite, with a gap between them. Add a collider 2D to each, so the bird crashes if it touches them. This is a solid obstacle, so leave those colliders as normal, non-trigger colliders. Here is the pipe script. It extends monobehavior, and it has a speed. In update, we move the whole pipe left. Transform.position plus equals vector 3.left, times speed, times time.delta time. Multiplying by delta time is what keeps it moving at the same pace on every machine, fast computer or slow. Then a cleanup check. If the pipe's X position drops below the left edge, say, -10, the pipe has gone off screen, so we call destroy on the GameObject. Without that line, old pipes pile up off screen forever and slowly eat your memory. Small habit, big difference. Now the magic step. Drag the finished pipe from the scene down into your project folder. That creates the prefab, a saved blueprint of the pipe. Delete the copy in the scene. From now on we spawn pipes from that prefab in code. Why bother with a prefab? Because it is a reusable template. Save it once, and you can stamp out 100 copies at runtime, each one independent. Change the prefab later and every copy updates. That is the instancing pattern, and you will lean on it in every project you ever make. So one pipe prefab knows how to slide itself left and clean itself up. Now we just need to keep making them. Time to spawn pipes on a timer. We need one more GameObject, an empty one called spawner, with its own script. This script owns the job of making new pipes. First, the script needs to know which prefab to spawn. We declare a public GameObject field called pipePrefab. Because it is public, it shows up as a slot in the inspector, and you just drag your pipe prefab onto it. No file paths in code, you wire it up by hand, once. Now, how do we fire on a repeating timer? Unity gives us invoke repeating. In start, we call invoke repeating, pass the name of our spawn method, a short delay to begin, and how often to repeat, say, every 1.5 seconds. Unity now calls that method on its own, forever. Here is the spawn method itself. First we pick a height. Random.range gives us a fresh random number between a low and a high value, so the gap sits in a different spot every time. That randomness is what keeps the game interesting. Then the key line, instantiate. We call instantiate with the pipe prefab, a position off the right edge at our random height, and a rotation. That one call turns the blueprint into a real, live pipe in the scene, and it immediately starts sliding left thanks to the script we already wrote. Notice how little code this is. Invoke repeating handles the when. Instantiate handles the copy. The pipe's own script handles the movement. Each piece does one job, that separation is what keeps a game readable as it grows. Press play now, and pipes march in from the right, forever, every 1.5 seconds, each at a new height. It is starting to feel like a real game. Let's count the score. The idea is simple. Put an invisible trigger zone in the gap of each pipe, and when the bird flies through it, award 1 point. On the pipe prefab, add one more child object with its own collider 2D, sitting in the gap. This time, tick the is trigger box. A trigger does not block anything, it just quietly notices when something passes through it. Give it a tag, so we know it is a score zone and not a wall. Now the display. Add a UI text element to the scene, Unity puts it on a canvas, which keeps it pinned to the screen so it never scrolls away with the pipes. Start its text at 0. Detecting the pass is one built-in method. On the bird, add onTriggerEnter 2D, Unity calls it automatically the instant the bird enters any trigger. We check the tag, if it is the score zone, we add a point. Adding the point is a tiny function. Bump a score integer by 1, then push it to the text with score.toString. ToString turns the number into text, because a UI text shows text, not raw numbers. One pass through the gap, 1 point, and the label updates instantly. That is the entire scoring system, a trigger, a built-in method, and a counter. No physics tricks, no distance math. This trigger and tag pattern is how a huge amount of Unity gameplay is built, and you just used it for real. Now the part that makes it a game, losing. Right now the bird can smack a pipe and nothing happens. Let's fix that, and add the restart. Remember the pipes have normal, solid colliders, while the score zone is a trigger. That difference does all the work for us. On the bird, add on collision enter 2D, Unity calls it whenever the bird physically collides with a solid object, a pipe, or the ground. A trigger will not fire it. A real crash will. Inside that method, we call game over. To keep things tidy, we put the score and the game over logic in a small manager script. It has one job for death: freeze the game and show the message. Time.timescale equals 0. That one line stops every moving thing at once, the bird, the pipes, the spawner, all frozen instantly. Then we switch on a game over panel, a bit of UI with the words game over and your final score. The player sees the crash and the message together. And the restart. When the player presses space again, we reload the scene. First set time.timescale back to 1, or the new game starts frozen. Then call sceneManager.loadScene, and pass the current scene's build index. That rebuilds the entire level from scratch, fresh bird, no pipes, score back to 0. Tap to die, tap to try again. Why reload the whole scene instead of resetting things by hand? Because load scene gives you a guaranteed clean slate. No leftover pipes, no stale score, no bugs from half-reset state. It is one line, and it is bulletproof. Take a breath, because that is a complete, playable game. Gravity, flap, scrolling pipes, scoring, death, and restart. From an empty scene. Let's make it feel finished. Polish is what separates a tutorial project from something you are proud to share, and none of it is hard. Add sound. Drop an audio source on the bird, and play a little blip in the flap code with play one shot. A second clip for the crash. Instant game feel, your ears sell the action. Add a scrolling background for a sense of speed, and then tune the numbers. Nudge the gravity scale, the flap force, the gap size, and the pipe speed until it feels fair but tense. That tuning is real game design. Trust your hands and playtest a lot. One more habit for later. Save the high score with player prefs, Unity's tiny built-in save system, so your best run survives closing the game. It is 2 lines, and it teaches you how saving works, which you will use in every game after this. Want more juice? 2 quick wins. Add a small particle burst when the bird dies, using a particle system, a cheap effect that reads as expensive. And a tiny screen shake on impact, by nudging the camera for a few frames. Players feel those touches even when they cannot name them. And give it a start screen. A simple menu scene with a play button, loaded first, makes the whole thing feel like a finished product instead of a demo. It is the same load scene trick you already know. That is the polish pass. Same tiny game, but now it looks and sounds like the real thing. And that is Flappy Bird, in Unity, built from nothing. You now know GameObjects, components, prefabs, rigid body physics, instantiate, triggers, and reloading a scene, the exact toolkit behind almost every 2D game. Here is your next move. Do not stop while it is fresh. Your next watch is lined up, Unity 2D platformer movement, where you build a controller that actually feels good, with coyote time and jump buffering. And if you want a full map, the GameDev Starter Kit's 30-day roadmap tells you what to build after Flappy Bird. Link below. Subscribe for more beginner Unity builds. Now go make the bird flap. See you in the next one.